gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist. I'd like to share with you some of my observations. In this report, I write about a brown dwarf star discovered in the inner solar system. On February 25, 2007, an object was seen traversing the Sun. Images from the stereo B EUVI detector testify to this event, as shown in Figure 1 below. The EUVI detector detects ultraviolet light in 4 different wavelengths. The images shown in Figure 1 are in the 304 angstrom or 30.4 nanometer wavelength. The object is dark in the first image, so it does not emit its own ultraviolet light. Here is the object in the first image. As you can see, it's black, so it does not emit ultraviolet light. But in subsequent images, the object is partially red, indicating that it is reflecting some of the ultraviolet light from the Sun. As you can see in the subsequent images, as the object traverses the Sun, it looks red, or at least partially red. And for that to be possible, it has to be in the Sun's corona and very close to the Sun. Figure 1, images of the Sun provided by the SETI stereo B EUVI detector in the 30.4 nanometer wavelength. From February 25, 2007, between 6:20 and 18:20 UTC at 1-hour intervals. An object is seen passing in front of the Sun. Having established that the object is very close to the Sun, we can now proceed to estimate its size. The object is about 1/6 the size of the Sun, and since Jupiter is 1/10 the size of the Sun, we can say that it is 1.7 times larger than Jupiter, or nearly twice as large as Jupiter. The object is therefore very large and about the size that brown dwarf stars are expected to be. Next, we will observe the same object in the stereo B Core 2 images. The Core 2 coronagraph observes the Sun's outer corona, so the object appears in the images long before it gets to the Sun. However, Figure 2 below shows the Core 2 images from when the object is about to go behind the occulter, and so closely approach the Sun, and also as it emerges after traversing it. Now the occulter is this black disk. Coronagraphs observe the Sun, but the Sun is too bright and it would overwhelm the detector, and therefore they use this dark disk to cover the brightness from the Sun. The white circle indicates the actual size of the Sun. In this first image, we see the object about to go behind the occulter. In the second image, it is behind the occulter, and it is behind the occulter in this third image. We can also see that the outer corona is dark in this third image, indicating that the Sun is reacting to the presence of the object, and it goes partially dark. In these images, here it is still behind the occulter, and here the object emerges from behind the occulter and proceeds outwards from the Sun in this direction. Figure 2, stereo B Core 2 images from February 24, 2007 at 5:03, February 25th at 7:03, 18:03, and 22:03, and February 26th at 4:18 and 12:18. Blue arrows indicate the object's position. In the Core 2 images, the object is seen to approach the Sun from below the Sun and then loop around the Sun and passing close to the Sun's surface. Figure 3 below shows the object of interest in an image from February 20th, 2007 at 9:03 UTC, when it is approaching the Sun and is still quite far from it. And here we see the object. It looks quite small in this image, but it's quite visible, and it is emitting light from the side opposite to the Sun. The fact that it is emitting light from that side indicates that it is not reflecting light from the Sun, but rather emitting its own light. Figure 3, stereo B core 2 image from February 20th, 2007 at 9:03 UTC. A blue arrow indicates the object of interest position as it approaches the sun. Figure 4 below shows a close-up view of this object. The object is black, but is surrounded by a cloud of gas that is emitting light, and the light emission is brightest and looks pink on the right-hand side of the object. And here is figure 4. As you can see, this is a close-up. I know it's not a very good image. It is the best that could have been done at the time. And as we can see, the object is emitting light from this side. And we can see the pink there, and we can see some formations around the object indicating that it is surrounded by a cloud of ionized gas. But a larger cloud of material, and this is referring to that cloud I have just shown you, is also extending around and some distance from the object. A dark object nearly twice as large as Jupiter, surrounded by a cloud of material which emits light, has to be a brown dwarf star, surrounded by a cloud of ionized gas. And the light emitted by the cloud has to come from plasma discharges across that cloud. So figure 4, close-up view of object of interest in a core 2B image from February 20th, 2007 at 9:03, showing what seems to be a brown dwarf star surrounded by a cloud of ionized gas. Plasma discharges in the cloud lead to light emission from the cloud of ionized gas surrounding the star. In conclusion, observational evidence provided by the Stereo B spacecraft suggests that the object that traversed across the Sun on February 25, 2007 is a brown dwarf star. This is Dr. Claudia Albers, Planet X